Right, ladies and gentlemen, we have started this course in what we call Linux, right? And one of the biggest things about Linux is the fact that we are working in a shell, right? We are working in a shell, okay? And while we are working in a shell, right, we have talked about a lot of things, what happens in a shell. Within the shell, there are a bunch of things we can do, right? We can copy, we can move, we can do multiple activities, we can check the IPs, we can do a bunch of things, right? So the goal is always that our goal is to look at a machine, always a machine, whether this machine is a bare metal server or it is a virtual machine. Next week, we are entering into a very practical topic. In fact, next week, we are going to build the first dashboard, our Grafana dashboards. Okay, why we are getting into all of this is because I want you to see the practical aspect of a working Linux environment. Working Linux environment is what you want to look at, but we'll talk about that. We want to talk about provisioning, configuration, what is a virtual machine, what are the different types of virtual box and all the different products on the market. Understand. So now that would sort out that part. Now there is a big question mark in everybody's mind. We are posting from day 47. We are today at day 62 or whatever day we are now. Right? We have all this material. Some of it is confusing. Some of it is clear. Some is even more worse than before. So we are always looking to reset. That is our approach. Reset, reset, reset. Where can we reset you so your mind stays focused in building on Linux? So today we are going to go into bash scripting. Okay, bash scripting, ladies and gentlemen, is something is it's not programming. Okay, people think oh programming. Maybe you guys have learned about programming like HTML is a programming. Okay, do how to make your web pages, CSS, Java. Okay, all of these languages that are out there, .NET, uh, multiple Python. We are going to learn Python. We are going to learn a programming language because we do want you to have a, you cannot live within the world today just like certain things for example, if you're using cash and money, right? Things have gravitated towards debit cards and credit cards. You can say I don't need any debit card and credit card. Well, you're going to be very isolated. Unfortunately, you need it. So this has become our need. Don't say, "Oh, I can't. I don't want to learn Python." How's it? But Khalid Khan, uh, God bless him, he suggested to me that let's start with Bash scripting. He's going to teach it in Urdu. He's an expert in Bash scripting in Ansible. So by talking about bash scripting, you will all appreciate how Linux works. You will see things coming together. Everything we have done. This is kind of like the brick and the mortar and the cement. Okay, so the first thing we want to do, right, is we want to know about our bash shell. Okay, so the first command anybody needs to learn, and which we talked about in the very beginning, is looking at uh, cat your Etsy shells, right? And we said that if you look at this configuration file, Etsy, right? We are going to talk. We have been saying all the time about configuration files, configure something, right? You got to learn how to configure, and that configuration is what makes things happen, right? So we have a configuration file. Let us clean this diagram completely. Uh, let's focus only on Bash scripting, and let us become. Everybody will walk away as an expert in Bash scripting. You take my word on that, inshallah. So let me just go here. Hmm. Excuse me. So we are going to look at Bash scripting, right? And we are looking at shell. So the first thing we have typed here is we need to find out the type of shells we have. And we have a command called cat etc shells. So that's the first thing we have learned today, right? Uh, okay. All right. Awesome. Same here, Khadija. All right. Perfect. Uh, and so this today will give you a very good focus on understanding where we are going with Linux, because we're gonna put a lot of through the week. You have small projects that would help you recognize what you have learned up to this point. Okay, everything that you have learned up to this point. How to you've used copy commands, you've used stat commands. Okay, so we are going to put everything together, and you're now actually at a company, working for a company. What do you do? So your manager says we will need to automate some tasks. So this is automation 101. Okay, so we're going to do automation 101. Okay. We talked about RSys logs and logging and cron, and very confusing. Everybody's understood it, but everybody's clear like mud. Literally everybody's clear like mud. Some people are like, okay, so there's some logging. So we are now moving towards enterprise. Okay, enterprise. How to handle enterprise. Okay. Now we are very well aware. I am very well aware that all of you are being very patient, and you are pretending to the best way you can that you know what you're talking about. But I do know also that deep down you're feeling like I'm still not getting it. I'm there, but I'm not there. Okay, so that's what we are here to. We have kind of loaded you with a lot of information, made you do some things. We're going to reset again for you. We're going to align you in the right direction. Your mindset will now become very clear. The road is going to be no longer in the jungle. So this is where we are starting with bash scripting, right? So all of you by today should know how to run this command. You cannot say to me, I don't know what a cat command is, and I don't know how to look inside a file. The file is called shells, right? And inside this shells file is under the Etsy folder. You should by now know the Etsy folder contains a lot of things, and we're going to play with it today a little bit. All right, we're going to play with stuff, and you're going to be like, "Whoa, okay, okay, that's kind of making sense." All right, so this is the wake up pill that we're going to take today, right? Now, we have been learning about using the echo command. Echo dollar uh, shell. If you put that in caps, okay, echo. So you're going to you run a command that's going to echo, meaning it's going to throw it in front of us. It's going to echo it out to us, and we're going to learn about this dollar, right? We're talking about, and then it's going to take a shell. What is a shell? And it's going to say you are currently working in the bin bash shell. So we are currently working in what kind of shell? Bin bash, the born again shell, which was when we started out with Unix, right? Unix was the pioneer, and then came Linux, right? And in Linux, you had a shell called sh shell, and then we got the bash shell, born again, right? It's like a born again shell. It is kind of moved on from here to here. So this is what we are reading here, right? We are reading a bin bash shell. So all of us are working in a shell. Okay, if you don't have a shell, okay, let's forget about we don't even have a shell. So if I exit here, right, and I type here cat etc shadow, it's not going to work. Cat is not recognized as an internal or external command, operable program or batch file. Aha, some idea it's telling us that hey, this particular command doesn't really clear. Clear is not recognized as an internal or external command, operable program, or a batch file. Batch file means when we run files, executable files, those are called batch files. Today we're going to learn about that. We're also going to learn about operable programs. So we know that this is not going to work in my um, this is our PowerShell command line. So this are not recognized. This shell does not recognize it. This particular shell does not recognize none of these commands. So we have to go into the bash shell. Okay. So by the only way we can do that is we need to SSH. All of you need to SSH into a Linux machine. And we know that the Linux machine is running and initialized, and at the end of the day it presents a command prompt. So let's look at what it does when I get inside it, right? It says okay, ABC, right? So it gets me and it presents to me a prompt. We have talked about it. It's PID1, System1. We got from the initialization files, and we are sitting at this point. We are here. We know a little bit of what happened to for us to get to this point, and we are going to learn a lot more about how we need to get to this point when we boot the machine. So next week we are going to talk about the boot process. There's a lot of jobs in the boot process world. Okay, it's a lot of demystification that needs to be done there. So now we kind of know we are sitting inside the shell, right? And we say, okay, echo my shell. I want to know what this shell is. Okay, and my shell is a bin bash shell, right? And it's an operable path. It's in an operable path called bin folder, right? We have folders that we know we can look into over here, and we can do ll, and we can see that we do have a folder called bin, right? Where's bin? Right here, right? Bin, user bin, right? So it says, okay, you have bin, you have some path, some operable path, right? This where this shell is loaded from, the files that are loaded up that make you do what you need to do and communicate with the hardware and get a response back to you is coming from here. Now, I don't think anybody should be confused at this stage because we are going over day one almost. Okay, very straightforward. So we can cat command. You should know what cat is. We should be able to go into etc, the directory, and under that directory, we know we have a bunch of stuff, right? LL under. If you just do a long, if you just do a, if you do a, if you just go into etc itself and do LL, you'll find all of these files. Now we haven't done sudoers, the sudo command. We haven't done a bunch of things there. By the end of the day, you will, when we finish this class, you would know pretty much 80 to 90% of these folders and commands. And the way we're building this is we haven't done all this cron work, right? We just kind of touched on it when we walked away. So, but we are coming back to it. We have made you aware of it. Well, we are coming back to it. We haven't forgotten about that. We're going to use the DNF to do provisioning, installation, configuration, right? Uh, Exports. We're going to use exports command. This is a command that works for us to define a path. Okay. So many things we still have host name, host, okay. Things you should become kind of familiar with when you just spend about 2 minutes, 3 minutes to open the etc folder, NF tables, network manager. You should just go through them, right? Password, file, etc password, open LDAP, OS release. We're going to work with this today. OS release. It's usually an interview question. Targets where we're going to do when we do talk about boot in, SE Linux, sudo. So yum repositories. We're going to talk about that. So we are system admins, right? We are system admins, and we have to clearly understand, like SSH folder. We talked about that last time. SSH, open SSH. If you go into, we haven't gone and opened the SSH folder, and we have some notes. If you CDSSH, clear LL, and then you have a bunch of files there, right? We looked at one which is SSH configuration that defines, but we didn't really work it out. We talked about a lot of the keys and how to work with the keys. So you are almost, I can guarantee you, 80% covered. The gaps that you haven't covered, we will cover them as we go forward in building a project. Because if we give you a project and you work on the project, all of this will clarify. Will come like we'll all click in one place because we need you to see this in a real working project. Okay. Um, I hope you're clear. If you're not clear, let me stop. Let me ask you. Anybody who has a question before I proceed, talking about bash scripting. Are we clear up to this point with everybody?
Yes, sir. Yes, Nadeem bhai.
Okay. Okay. Great. Very good. You can we are taking things uh bite size. Okay. Now, so what we want to do here is we want to do some bash scripting today. And we said, okay, if I go into the Etsy folder, I can find a file called CD in my Etsy LL. I could find a file called shell, SHELL, shells. So there is a file called shells. There you go. So every time I type Etsy to you, you should take it upon yourself after the class, anytime during the week, take it upon yourself rather than thinking about, oh, I'm getting confused. The only time confusion will go out of your mind is go into the Etsy folder, take a cup of coffee, cup of tea, a cup of faluda, whatever you like, ice cream, whatever you enjoy most. Sit down and look at your clock on the counter here. It's 11:28 for me. Okay, I'm going to give 5 minutes to this folder. Let me start from here. What do I know? Nothing here, nothing bash. Okay, we do bash RC. Prawny? No, we haven't done prawny. Okay, we haven't done that. So this is how you know Linux. This is your roadmap. People say, why don't you give us a roadmap to Linux? This is your roadmap to Linux. Right here. You know this, you know Linux. People say, "Well, give me a roadmap. Copy command. Yes, that's fine. But this is the configuration folder. This is a configuration folder, has the largest number of files. This is what a system admin should be configuring anything in the Linux system. This is the doorway to Linux. You come here, you know this, you know Linux. You don't know any of this or some of this you're not clear about, you are not a Linux guy. Okay? So take the time to look at each one of them, examine two or three of them. Oh, sudoers, let me open this, let me open this. Prepare yourself for what's coming your way, right? Oh, what is that? Open Chat GPT, open Gemini, open Claude, open something else other than uh, not wanting to look into. Don't use Google for the searches. Google isn't really it's a good engine, not the greatest engine. Today we got Chat GPT, we got Gemini, we got DeepSeek, we got multiple engines. Start throwing it in there and say, oh, okay, let me grab this file. NS switch, what is that? Okay. Don't waste too much time. Just, well, like I said, skim through it. Skim through it. Okay, this is our path. This is our journey. Are we there yet? No, we are not. I can tell you we're not there yet. Okay. So we have a file called shells. Okay. So that the journey for bash scripting starts from where? Everyone? From shell.
from
The
the shell.
journey of bash scripting starts by looking at the shell. So let's look at the shell, the most important thing. It is not shell, it is shells. So I've got to type in cat shells. So it's telling me that we've got a bunch of shells here. Now, when I ran this command, cat /etc shells, I was just looking at what's inside the shells file. And I was able to see all these shells. I have bin bash, I have a bin. This is a Unix shell. This is a Linux shell, right? We can install other shells like the ZH shell, but 99.9% of the time you don't need that because Linux is operating off of bin bash, and we are here to learn the bash scripting, how to master this shell. You become a master of this shell. Control this shell, play with this shell, and after today, you're going to walk away as a master in bash scripting. Okay? And I guarantee you that. That's my word to you. If you pay attention to what I'm going to do today, I'm going to teach it very step by step and simple and easy for you. And then we'll talk about what's posted up there. Now, we're not going to run any change your shell command. No need for that. Okay. You can, if you want to practice it, you can practice it. I wouldn't waste my time on it. No company has ever asked me to change the shell. No project I worked on, I had to change the shell. So nobody cares if you know how to change a shell. So ignore that. Okay. We learned about user mod command. Okay. User mod. If you go into your manual for user mod, right? In user mod, you had so many different flags. One of the flags is S flag. S as in Samuel. S as in Sam. Uh, so S stands for shell. If you go back into my notes, where I discuss the overview of the user mod command, if you wanted to add a user and you wanted to use a flag -u, right? Um, so one of the projects we'll do is create a user management, automated user management. Like in a company, most companies don't go and say, okay, user add this. No. So we're going to get to the sophisticated part. Let's build one block at a time. You understand the -u is if I want to say user add -u, I can give a numerical value, let's say 2000. All my developer dev 1, dev 2, dev 3 users will be 2000, 2002. Let's say I want to create all my PT environment folks. So those are going to be QA1, QA2, QA3. Their category is going to be what? So you can have user mod, right? I mean user add. We have just been at user add Mary. Okay, this is just for test purposes. This is test. This is not real world. Nobody does this. Okay, this is just test. Remember that. So when you see YouTube channels, you're learning about user management. Nobody tells you that this is test. They say, oh, you're going to create a user ad. No. So that is user ad. In real world, you're going to need a flag -u. I'm going to give a numerical value of 2000 and I'm going to create dev 1. Anybody tell me what I'm trying to do here? Because my dev 2 will be 2001. My dev 3 will be 2003. So now we have already learned this, these flags. If you don't know where the flag is, use the man command. Man, right? And then user add or user mod. Okay, any of these. So make use of the manual command. Manual. You have a manual in the system. Use it. You don't understand something before you go to YouTube, Chat GPT, type manual. MAN. Put it in your head. You're on the RHCSA exam. MAN. MAN may save you the day. Okay. So we have a flag that we want to look at, right? And the flag is, what flag are we looking at? We're looking at -s flag, which is a shell flag. Okay. There's a -b flag. There's a -p flag. We don't need all of them, but we just need two or three flags is all we need to learn about. You're not going to do user management in today's Linux other than for testing purposes. So the path of the user's new login shell, right, is -s. Okay. So let's clear that. Let me come out of this. Let me press Q. Okay. So if I did a user mod and I wanted to modify user mod with a -s, what is that -s trying to do? I'm trying to change the guy's shell. Okay. So if you want to change it to bin bash, let's say a particular user was using a Z shell and you want to bring them back to so you just put the username here, let's say John. So that user mod is saying, hey, run this command. What we are going to do is we are going to implement this flag, which is to implement this shell and assign this shell to John. Okay, no need to worry about it. That's not for part of bash scripting. That's one of the steps in bash scripting you must know. You should understand the user mod and user add. By now, I'm sure you have looked at that. But uh, what we are going to do for today, right, is we are going to create a directory. Okay, let's look at CD, okay, clear and PWD. I'm going to make a directory, -p, very simple directory called scripts. Okay, so if I do a PLL, I have a directory called scripts. I will go into the directory called scripts because I would like to put all my scripts in one place. So all my scripts will be in one place. When we say clean your file, literally you can just remove, you can just delete. I mean, you can delete this folder, or you can do rm-rf space star. You can remove all the files underneath, and your machine is back to normal. You can clean up this. So we are going to do all our scripts under scripts. Okay, we put the scripts there. Fine. Now, under the scripts file, cd scripts, right? Let us create our first script. Let us create let us create our first script. Now, I'm sure a lot of people sitting here who already know this stuff are saying, what a waste of my time. I already know this stuff. Maybe you will get something out of it that you have missed. You'll be surprised. Okay. So we are going to create to use a touch command and we just say, hello. What should we call this one? Um Hello script. Very popular. Everybody starts with this. We'll start with that as well. But eventually, we're going to do things like a system uh, when we do our project, where we are going to do something like, let me tell you where you're going to use this, right? You're going to have, for example, multiple virtual machines sitting here, multiple virtual machines sitting here, right? And you're going to have a single virtual machine, right? Whereby you're going to take all the inputs coming from each of these machines, pretty much into this. Okay, you're going to run a bash script, and you want to look at using the bash script. You are trying to find out in that script different conditions on each of these servers, two, three, four. And the modern reason why we don't use the bash script anymore for this kind of the old school is because we have Grafana, and we can take Grafana to create for us from each of these machines. It can actually bring out the data and bring it to a single machine, and we can have this single machine connected to Grafana. So we this is our new way, and this is our old way. But we have to talk about the old ways because the old ways teach us how we have moved into the new realm of doing things. So we were used to run bash scripts here, and these bash scripts were like, okay, give me this server number one. So you run a bash script here by bash script in this server, and this server, this server, and this server. And the output of that bash script, the output files got all into this one. You'll have an output file from server one output file, server two output file, and now you would take this output file, and then we would actually run like a top command or something to review the data inside it. This is the old school. Okay, we have gone away from it. But for learning Bash scripting, you will see the value of it. Now, Bash scripting is still being used for log rotate, for running operations and tasks, automating things. So Bash script is kind of now limited to just the machine. We are no longer using Bash scripting for system level work. System level work is all done through Ansible. Okay, it's now done through automation tools like Grafana, Dynatrace, Splunk, right? Those new tools, multi-million dollar tools have come out to resolve the system level overview. You want to see these servers, you don't need bash scripts anymore. Okay. So the value of bash scripting is going to be you're only looking at one machine. That's it. One machine at a time. But we will do a multi-machine project too, just so you can understand how bash scripting sets the road or paves the way to understanding the new technologies. So we are local, always in bash scripting. We're not system level anymore. Okay, so let us go to bash scripting. We are going to be looking at, I'll put it here for you. Bash scripting, our focus is one single machine. Okay, that's it. We are running this bash scripts here in one bash scripts. It's only one machine, one bare metal server or one virtual machine, one VM per VM, per VM, you can say per VM. Okay. So that's what we are learning today. And what we are going to master is how to run a bash script within a shell. I'm sitting in this VM. This whole thing over here is the VM I'm looking at, right? So so that's what we are trying to do. Okay. Now create a touch command, and we're going to create a file called hello.sh, and I can see that I've got a file called hello.sh. Now, we haven't done, I think, DNF install, I think, Vim. Vim is one of the editors that people like, and you can run a DNF install Vim -y, and you should be able to just install the Vim editor, which is a much better editor than VI, but I'll use VI because VI is the old editor, still works fine. In fact, 90% of the data centers and enterprises are still using VI. Nobody's using Nano. There is Vim. There is Kate. And these are all editors, right? These are all editors. We are learning. We can use Vim editor. We can use VI editor. So I'll use the VI, and I'll show you the difference between VI and Vim. So VI is an editor. Okay, it's a command. You're going to edit a file. So we're going to edit a file called hello.sh. Where is this hello.sh? Okay, it's sitting right there in front of you. I want to go ahead and open the file. I want to open the file, and I want to go inside and write inside this file and save something in the file. So if the editor is VI. Okay, so and I'm going to apply this editing on hello.sh, and I'm inside the editor now. In this editor, there are a few things to keep in mind when you're in the editor. Okay, so in the editor, if you press the on your keyboard, if you press the key which is between the U and the O key, which is the I, just one stick. You have a U key and the O key. Between them, you have a key called the I key. This I key is called insert. Insert. What does insert mean? Anybody?
Yeah, it will start writing to this
Right.
file.
Right. I want to insert. Straightforward. Let me press I. I press I on my keyboard, and if I go here, sorry, let me click here. I. The minute I press I, it says your editor is ready to insert. Meaning I can come to the top over here and I can insert whatever I want. Now, if I wanted to delete this, I can do backspace, right? But you have two things to learn and three things that you must master. Okay, number one, when you are inside the editor, if you press I on your keyboard, your key I, this will allow you to insert. Okay, but if you press the escape key on your keyboard, right? It will take you out of the insert mode, and it will take you basically, it is getting you ready to exit, ready to, it's getting you ready to do a couple of tasks. For example, you can run DD on every line, just DD, it will delete everything on that line. So let me show you. And then the last thing is you can press the shift key on your board. Okay, and then you press plus the colon key. Okay, if you press the colon key, it will now shift colon will give you a prompt like this at the very bottom of the machine. You'll see these two prompts. Here you can write you can do W, which is for write. That's one way you can do it, and then that's not going to work by itself. So you'll have to do W, and then you'll have to do Q to quit. So here you have to say write, right, and then and quit, quit. Okay. If this fails, if you see a command to fail and you see like a red line at the bottom of your screen, don't panic. Always press shift and colon. Just press that. Shift colon, and you go back here again. Let's say you don't want to make any changes. You can just press Q, quit, and you are out. Let's say that doesn't work. Again, so you throws this red little strip at the bottom. You'll get a red thing, read only, something like that appears all in the bottom here. You get a red, something in red showing in the bottom here like this. Don't worry about that. Just press, always, nothing to panic. Press escape. You press escape a few times, then press shift and colon. If you got a red one, in order to fix this red problem, okay, what do? In order to fix this problem of the red, You'll have colon, Q, exclamation mark. This means force, by force, by force. Okay?
I have a
So,
question. Can we
yeah.
skip the I part and just click on escape in order to start adding?
No, you can't.
You can't? Okay.
Yeah. You have to go insert. Insert is the de facto uh, prompt that allows you to insert in the shell. That's how the editor works. Yeah. So you can quit. You can this is to quit. Okay. The other thing you can also do is if you were to you wanted to write it and save it, because especially if you get a red bar, I would not want to write anything to it. That means I don't want to write anything. That something is not right. So this is your safest command to run if you get a red. Okay. There's another command which you can use, which is uh, X, just X. X here equals, this is the same thing as WQ. This is the new form as they're introduced now. So you don't have to type WQ, you can just type X at the bottom and there you go and hit enter. And it right here, it will work. So at the bottom of the screen, you will when you press this, you will see this happening at the bottom of the screen, right? It's going to take you at the bottom. If you run any of this right, that's not going to work. So right always works with. So this is not. This works. Okay. Uh, and this works. And this works. These are the three that work. And if you have a problem, you just put Q and exit. Do not. If you see a red, don't write. You can also write. You can also do W Q and prompt if you're 100% sure of what you're doing. This will work too. So write. You're saving what you're writing. You're saving your work and you're exiting. So exit or exit the editor, right? Exit, the same thing as exit. Exit the editor. Are we clear? Now there are some things will there's some editor short keys that I'll post for you guys, and you can use them later on. But for now, we this is essentially, if you know this, you can never go wrong in Bash scripting. Okay. So let's remove all of this, clear all. All right. So I have to, if I do escape, you see that this insert will go if once I press escape, gone. You can see this thing blinking on the bottom here. You see, telling me that I'm pressing escape. I'm playing it, and I'll have a blink blink noise going on in the back. Okay. And then, so let me go insert. Okay. Now my cursor is ready. I can take it down. I can take it up. Okay. So as long as I'm in insert mode, I can insert something to it. Okay. Now, we can insert a very simple statement called echo. Um, uh, Hello, team NIT. Okay. And we can leave it at that. Okay. And we can go X, like you see, WQ, that'll work. So I will go with WQ, enter. Okay. I can cat this script and I can see that it has this hello team NIT. And it's also showing you that you have left some gaps and something we're doing. So here's hello team NIT. So by simply, sorry, that we are catting this. So now if I wanted to run this script, right, I can't really run this script because it just has, if I just do bash hello.sh, this will tell you what's just inside there. It's just going to echo it out to you just by simply running a bash command, bash hello.sh, and you have this coming out. But that's not a true bash script, right? That's just you don't want that. We want to be a little bit more sophisticated about that. So let's go vi into hello.sh and let's add something which is important. You need to, the way you'll memorize this is we have hash, right? Okay. Hash. Hash is like this. Then you have an exclamation mark, and then you have this is what initiates the bash script for you. Okay. This is what tells you that this is your bash script. So one second here. Let me see here. We're not doing, let me look at my notes. Okay, good. So this right here is there is a name given to this. They call it so the word is hash. So if you take the sh part of it, you take the a and sh, that's what the sh means, and they've just added to this sh, which is like a hush, shebang, and they've just added to this a uh, shebang. That's saying that way you can never forget that your shell, this sh is sh as well, and bang. So you're going to put pound, dollar, bin bash. Okay. So this tells, okay, what is this happening? Okay. So this tells the operating system, hey, this isn't just a random text file. Remember, this isn't some kind of random thing we put over here. This is no longer random. If you put this at the very first top of a script, right? You're basically saying, please use the bash interpreter. Use the bash interpreter located in this path at bin bash to read and execute these commands. I would like shebang, meaning I would like you to make this command right here is telling you go and read here in the bin bash, right? And anything we are going to do after this, we are going to be we need to read, okay, and execute. So we are going to read and execute commands. So whatever I'm going to put down here after we, so let me show you. Uh, right. So if I go up here, so how people always forget, should I put the exclamation mark first? Okay, insert. I can't do anything with escape. Okay, I can't do anything with escape. So I have to go escape, insert, and then the shebang the reason why it's called shebang is that it allowed people as a mnemonic to remember what to put in the very first thing, which is the hash. Shebang should be hash. So you don't forget that. And then the exclamation mark, and then the path, bin bash. Okay. Now you're telling the in this script, you're telling them that, hey, this isn't just a random text file. Please use the bash interpreter. Use the bash interpreter located in this location, right? To read and execute whatever we're going to write over here. Whatever we're going to write here, I want you to go ahead and read it and execute it for me. So that's why you put this. This is an interview question. This is an interview question. They've asked me this 3 times in 3 different interviews, right? And they say, okay, so how do you know that you're ready to write a script? Well, you have to have the shebang. Without this, this file is just looking at just echo. It's not going to do anything. It's not going to execute. It's not going to run anything for you. It has nothing. It just looks it as plain text. That's it. It's like a text file, right? Like the Etsy shadow file. It's a text file. You have a bunch of text sitting here, right? Look at this. Let me escape this. Let me quit. I haven't made my changes. Now look, I tried to quit and it says, listen, no write since last change. Meaning you've written something here and you're trying to just press the quit command, the Q, but you're not saving this. Are you trying? So this is like how you get in Windows a prompt that says, do you want to save your work or do you just want to exit without saving your work? So I should say, oh, it says you did not write your stuff. You haven't saved your work. So if that's your case and you want to override this, we're giving you this warning like you don't want to save your work, just add the exclamation to the queue and your work will not be saved. there'll be no write to this file. So I have to press escape. Now, when I press escape, this is hidden at the bottom. This is E37, this is all hidden. I can't see anything. So what I have to do is keep looking at the red line, press my shift, press my colon. There you go. The line goes away. Now, this is going to give an error to me. Why? Tell me again, everybody. Why is that giving me an error? Because I'm not writing it. I'm not saving my work. So I need to save my work with writing it, and I want to quit. Okay. Now the red line will go away. I'm writing it and then I'm saving it, and I'm now exiting it. There you go. So it has done the job. Are we clear, everybody? Are we clear?
Yes.
Yes, sir.
You cannot believe me. You can never miss this bash scripting as a rocket science anymore. It's very straightforward. So let's go in here. Okay. And so we have added something to this script over here. Now we can cat it hello.sh. Okay, but there is no command to run or nothing to do in this mode at the moment, right? Because the only thing it's going to do is going to read this echo and run it. So let's try to let me vi into hello.sh again, and I have all this stuff. Okay, dd 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 dd. Okay, let's see. Okay, I've just dd dd dd. Okay, let's go up, and we leave that space up there. So I will write those changes again and quit, and let's clear this now. Now, how do you execute a script? Anybody? Any of you have done it before? How do you execute a script? Okay. So if I look at my script, let me show you. There is my script. How can you make it is now look at the permission on the script, right? Do you see any X? Yeah, somebody wanted to say something. Go ahead.
Oh, yes, I was about to say to change the mode of execution.
Very good. And everybody should know that any text file, it's following the regular 644 permissions from the umask. So hello.sh file is just a 644 permission. We learned about permissions that any file you create has a 644 permission. So you can see clearly it has a 4 plus 2, read 4, write 2, which is 6, and then 644. So we can see that stat of hello.sh, it is 644, right? That is a permission. We haven't done all of this access modify stuff. Don't worry about it. We haven't done hard links, soft links. Don't worry about that. We have done a bunch of things here. We'll get to them. Don't worry about that. As the time comes, we will catch up and learn, right? So if I look at ls, if I just look at ls-l, I can see that my permission is, I don't have. So this is my user. Now, all of you who have been revising, your user, right? And your group, right? And your others, right? So we have currently this file permission is read, write, and dash, and read dash dash, and read dash dash. What is missing in all of this is the user, this user needs to have read, write, and X, right? The user here is root. If you want these people to get X, then you have to change and modify for others. If you're working in the company, if it is about a group that needs to have access to this, you can put the X over here for the group. If you want to give it to others, you can put X and you can have. So we can do it. We can do it different ways, right? One of the ways for doing for the user is Chamod, which is very popular. User plus X, right? But if you just did plus X, hello.sh. So let's do u plus X first. So u plus X, hello.sh. And if I do ll, I can see that I've added from read write, I've given them the access to the color has changed from being a typical file to getting a green color, right? Sometimes in some companies, this color becomes blue. Okay. So we are going to talk about a script and how colors are changed. The default colors here are, I think, are green. So now what we have done is we have made it executable. That's what we have done here. That's what it means to make it executable, meaning we are able to run it now. And we have two things we have learned all along is that if you put a dot, right, and you put a dot, uh, it means what does this dot mean? And if you put a double dot, what does that mean? This means your current directory. I'm in my current directory. Okay, in my current directory. Okay, I'm now in my parent directory. Are we clear, everybody? Are we clear? Are we clear? Do you
Right.
understand this?
Yes, Nitin bhai.
Yeah. Okay. So 2 dots, parent directory. 1 dot, current directory. So I'm going to come over here and I'm going to put in, if I did cd dot dot, because if I'm doing pwd, this is my parent directory. This is my current directory. I'm in my current directory. So if I'm in my current directory, if I go to cd dot dot dot, I am now in my parent directory, right? If I do pwd, I'm in my parent directory. If I go cd, if I go change my directory to scripts and I do pwd, now I'm in my current directory because I did pwd is my present working directory, pwd. So that's a dot. That's a dot. So if I have to put a dot, okay, if I put a dot here and let's look at my scripts here. Let's look at the listing of, I have one script. What have I done? I have changed its permission. If I don't change the permission days to X, this script is not going to run. So if I put dot and I put a forward slash, okay, and I put in hello.sh, this is how now in applications, we are going to see start.sh. We're going to see stop when we guys are going to do we're going to do DevOps. We are going to use, you're going to see, you're going to write a script called start.sh that will start the Docker container. When we do a stop.sh, that is going to run the stop an application. So when you guys down the line find out the secret of the world, because the world started out, I had Aurangzeb. I'm going to take a little diversion here. There was in around 2001, 2002, the world was introduced to Visual Basic 6. Okay, Basic 6. This was the groundbreaking technology that revolutionized and created companies like what do you have this like Emerson. Emerson, if you go and look at them, Emerson. These are all instrumentation and control companies. They gave rise to the things like the SCADA systems, PLCs. Okay, this is the whole world of technology of fourth generation, third generation technologies that are still out there, still, right? Made the word GUI possible. GUI became a reality. What do you mean by GUI? So if you're sitting in a lab, this was the first open source open source technology in the testing world. What do you mean by that? If you are sitting inside, you had a glass and you want to go and buy, you had water inside it and you put in a probe like that, right? And you have a little sensor, a temperature sensor that had two wires going out to it, right? And you can put that to what was known as a digital to analog converter card. You were able to bring that into Visual Basic, and that data that is coming, the real-time data that was coming here, you can go into Visual Basic and you can create like a bash script that would have a button over here, and you can name this button start, right? and you can create a button called stop. Okay. And what that was really doing was it was actually a script. A script was running a visual basic script program. They used to call them subroutines. Subroutines that was running in the back. So this program will run. It'll be a script, and the script will say, "Okay, go in here, communicate with the DAC, open and see what data is coming through, and give me that digital information and convert it and display it for me." And you would have a nice display of your temperature, of your water here is now 82 degrees Fahrenheit. This was the first time the world was able to display it, even though they were doing it before, but this was Visual Basic 6 was a groundbreaking technology in object-oriented programming. Then came C++ and object orientation, and all these companies till today, the billion-dollar companies that you hear, Emerson, one of them big ones, all these control companies, all these PLC companies, they all ran Visual Basic. They started with Visual Basic. It was free and revolutionized this industry to make money off of it. Now you can go to a customer and say, "Oh, I can test your tire pressure." So if you remember, the old cars you could never tell the tire. Today you have TSP, a tire pressure sensor, tire pressure TPS, a tire pressure sensor. Your tire is over here. You got a wheel. You got a sensor over here, and it is telling you on the dashboard if you see a red light that your tire pressure is not good. So this is all Visual Basic that started this revolution. Okay, so understand this, that when we run a script called stop.sh, it is like you are pressing a button over here. You're pressing a button. Okay, when you press this button, you're going to run a script. You're going to run a script, and the output of that script is what you're interested in. What do you want to get out of it? Okay, that's all we're trying to do here. That's bash scripting. That's where the world of automation is. There's not a lot of information to soak in. So let's clear all of that. We said, okay, that we can run a script here. What is our script name? Hello.sh. Okay. So there you go. Give you an output. Simple and short. Okay. So what have we learned? We're going to take a break now. And what have we learned in the next hour? We're going to build on this. It'll be very fun. What have we learned so far? We learned that we have a shebang command, okay, with a exclamation, bin bash, okay. We also learned that let's do number one, make a directory, mkdir, okay, -p called scripts. Then we went inside the scripts directory and we used the touch command and we created a file called hello, okay, which I don't like it at all because it's not very practical, but it's used for teaching purposes. And then in the hello file, we went into the VI editor, which is number 3. We went into the VI editor, okay, and we are able to go inside here, learn about the VI editor, exit the editor. We added a command, echo whatever we wanted to add inside here in between. And we are seeing that output right in front of us. Let's take a break. Let's come back in it's 12:10. Let's take a 10-minute break and come back.
अस्सलामुअलैकुम नदीम भाई क्वेश्चन कर
जी वालेकुम सलाम।
भी क्वेश्चन कर लूँ या
हाँ कर लें
ये आखिरी वाला मुझे समझ नहीं आया।
Right. So we have talked about what is a shebang. The word shebang comes from the hash, called hash, followed by this. We have talked about that. Why is it called shebang? In the Linux community, it's commonly called shebang, hash bang, or shebang. Okay. So at the beginning of a script, we have talked about that. Why do we need the shebang command? It tells Linux which interpreter should execute the script, which is the bin bash interpreter. Okay. Script structure, we just did this. Why must it be the first line? Check the first line of the executable print. Okay. The program runs on the first line. Okay, that we have talked about it. So guys, this is all we have covered all of this. We're going to cover, I think, up to section 3 today. So anyway, we will come back to the end of this one, because if we go through this and you're following my video is following my own notes, which are here. Some one or two small things maybe are out of place, but most of everything is there, right? Alternatively, we can do it this way. This grants execution permissions. You should know this is very straightforward. It's like a 5 minute, 3 to 5 minute read, not even 3 minutes. Running the script, I'll put it in Urdu. It's not in Urdu ready yet. I just did the English. So run the script, hello script, we did that. Linux reads the first line, it reads the shebang line, starts the bash, bash executes the command, hello world is the hello friend is the output. How do we use this command? Okay, so here the dot represents the current directory. I've talked about that. PWD, which is the current directory. Um, I had it for a user called Elliot, but I'm not using that. I'm going to change that. That was what we used last time. We don't have that this time. So most important is current directory, right, which is dot, and your parent directory, double dot. Okay, we have learned all of that. Now, why doesn't this work? Suppose you just type hello.sh, right? Command not found, because Linux searches only the directories listed in the path. So let's look at the path review. The next thing we're going to do is run our machine here. Okay, we have done this. And if we run that, it will give us an output. So we have the flow diagram. The flow diagram is, I gave the flow diagram over here to you, which is right here, execution flow, right? It flows like this, and you get a hello command, and this is the output. This is what you get the output. So the flow is over here in your notes, right? You can see the item number 2. Okay. Now, next thing is um, understanding the path. Okay. This is we talked about path, and probably everybody is still confused when we said path, path, path. Okay. Now we did say that if we echo $path, $path, right? If we echo $path, it gives us uh, the where to find all the exit. When you type in ls, ls or ls hyphen l, right? Pwd. By you just typing that command, it checks into each of these directories to see where to find this pwd. We talked about that. That is the path. This is the path. Okay. So if I now just typed in uh, 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 ll, if I just typed in hello.sh, says command not found. Why? Anybody can explain me why when I'm typing hello.sh, nothing is being found? Anybody?
We did not start with the script like dot
Because
slash.
Very
because
good.
it wasn't interpreted.
Right. Yeah. So there are two things that you need to find, clear your concept, everybody. The concept that is always confusing to people is the path concept. Okay. Everybody, so what is the path? How do we? Now, a path just basically means in Linux that anything that is over here, anything, the Arabs, they say kulla shay, anything, everything, if anything that you're talking about, PWD, any commands, by path, the $path means that if it is in the path, Linux recognizes this at the dollar prompt or the hash prompt. If you type something here, it's going to recognize it. Okay, it doesn't need anything because it's going to go into this path and probably find a folder, and maybe under that folder you may have this pwd. So it has a path. Now, when you just type hello.sh, it does not exist in any path. There's no path in it. Now, a lot of the developers, and when you get into application in a lot of companies, when we do DevOps, especially DevOps, when we have to write, where we have to say, okay, we want to start a script. Okay, start dot sh. We want to start a container. Okay, we want to start a container. We're getting very close to learning all of this. Trust me. So that's why we want to introduce you. Remember in your mind, if I had a script here called dot start dot sh. Now, we will see next week when we build the Grafana dashboard, the directory will be the path, the directories we're going to create could be like this: opt/opt/guacamole, okay, slash um, scripts slash you could have what do you call your what do you call this thing in the application? You could have logs, and under logs you can have a start dot sh. Okay, look at the path. Look at how long this path is. So every time you want to execute this command, you'll have to put dot present directory /. Then you got to give all of this path. You got to put all this path right all the way, including the start dot sh. Uh, sorry, or you have to go inside this file all the way here and just start with Dr. start.sh. Sorry, not that way. You will have to go inside that file, have to go all the way inside and start it from there. So there is a way to add a path to all of this, right? You can add a path, a clear all. And the way to do this is we have a command called let's see. Should I add that or export? Okay, we can do that. So we have a command called export command. Export. Remember this, memorize it, export. So what you're trying to do is you're going to export your appending. This is what you're trying to do. You're trying to append. Append meaning you're trying to attach to this one. You want to come over here, put two dots, and you want to append a path. Okay, you're exporting this path. Okay, and you're going to put it over here. That's what you're trying to do. Okay, so clear all. We're going to clear that. Export. We don't have to do it right now, but I'm just showing you the way we're going to do it. Later on, we can use this command and add the path if you wanted to add the path. So if we add the path, dollar path, okay, colon, and my path is what? PWD, right? I want to find my path. My path is PWD is my path. So I'm going to do export, export path, dollar path. Now, you could be working for a company and they can tell you, we need you to make sure that you add this script to the path. That's why I'm teaching you this. You're wondering why are we learning this? What's the value of learning this? Because a company just wants it to be a script they're going to use all the time, every time to execute. They want it in the path. They want it defined as something that you don't have to keep on manually typing dot / to or find a whole path to it. So we can just give it a path, which is the PWD path, which is this one. This is your path, and there you go. Now, okay. So if I do that, okay, what's that going to do? We are going to append this path, and it's going to become a part of anything I'm going to run in there. And for now, I'm going to do it. I'm not going to show you how to remove it, but I'm going to just add it in there. Okay, not a valid identifier. All right. What do we have there? Path. Is it script or scripts? It is scripts. Export path. Let me see. What am I doing wrong here? Yeah, Hassan, you saying something? What am I missing in the root? Okay. We have a typo. Okay. And typo is where? Oh. Oh, sorry. Equal. Could have missed that one. That's the connection. That's the equal. And that would actually add it to the path. Yep. Now it has added that to the path. Okay. So if I just ran my script, now let me go CD. I can be anywhere let me go to C directory TMP. If I'm in the temp directory and run PWD, it runs. it runs. I'm in the temp directory anywhere because Linux recognizes that this particular anything under that path, anything. So what do we mean by that? Anybody can explain to me what I'm trying to do, so we can maybe have a discussion to help each other. Thank you, Azim. Thank you. Appreciate that. So we are going into CD CD scripts. Okay. Now, if I decided to touch and have, which we are going to have cron.sh, and we have a touch, we're going to have system dot sh, touch start.sh, sorry, touch uh, touch start stop.sh. Now, all I have to do anytime in my system, I can just type start.sh. Well, we don't have a script like that because, as you all know, we haven't built those scripts. Those are permission denied. They're not green. We have nothing yet. We haven't done this project, right? So we are going to create all these scripts under the script directory, and I can just do start.sh. I wouldn't have to go, CD, OPT, and this, and then this, and then this, and then enter inside, and then go right. And I don't have to do dot / hello dot sh because as I explained to you, this is saying look at my present. This is always run manually. Dot is your present working directory. I can do that too. Look, it's going to run. But I have to type the present working directory and tell him to look in this folder and then type this. By adding the export command, by exporting this path equal to $path, $path, right? Colon / root. Now, if I look at just the path, echo $path. Look at that. I have something in my path called root scripts. Beautifly. I can now just run anything. I don't have to do present working directory and look at my present working directory and not only my directory but look at the folder as well. And then in this folder look for hello.sh. No, I can just type hello.sh because now Linux recognizes that path, that anything that's going to be under the scripts and anything under that script, just like anything under bin. So if under bin you got pwd, it will type it. If under scripts you got hello.sh, it will go all the way down and it will find root and it will find scripts. And since this is under scripts, it's going to execute it without any path. Are we clear? Good. Yeah, if you're clear as mud, let me raise your hand and ask me. If you're not, let's move on to real beef. Let's get some steak and barbecue going. I hope you're clear. I hope you understand what we're doing so far. And this is making sense. Is anybody confused? Hassan
Uh,
Dastagir, are you
in-
clear?
And anyway, I have a question. So in
Yes.
this case, let's say, if we add the path, so in that case, our names should be unique. Our script names should be unique, right? Because
Right.
now in any directory, if we can, execute any script, then the script names should be unique in that regards.
Yes. Yes, you're
Okay.
very right. You're very right. And it is not very common to do this, but this is when dev teams, SIT teams, when we learn DevOps, I said to you very clearly, DevOps people need this. Why do DevOps people need this? Because आप develop कर रहे हैं, you're developing something. And while you're developing, you have to maybe write 2, 3, 4 scripts. Every time dot / hello, dot / dot. So you get tired. You're writing a script, you're adding to the script, you have a 2-week project, you're working to do a DevOps script. And every time you have to come out and save your work and do dot / Now, what you could do is you could have one terminal open on one side, you have another terminal open on another side. So you have two different terminals. Maybe on one terminal, you're investigating a command, you're looking at what you need to do. On the right hand side, you are doing some testing. So now, anywhere in your Linux system, you can just type hello.sh, right? Or
Okay.
start.sh, and you can test it. So, in the test environment, you brought a very good question. In the test environment, this is perfect. In the production environment, you don't see this at all. Very good question. Yes, in the test environment, you give a path, but in the production, you don't give a path because if somebody runs it accidentally, it's a problem, right? So things have to be run through an application. An application will have a symlink. That's why we're going to talk about symlink. So let's say you have something sitting over here, and you will create a symlink, and using the symlink, you're going to execute. When the program completes, it will come back to the same, run the script, come out of the script, get the thing done, and you're out. So we are going to talk about symlinks later on. Very easy, straightforward. One line to learn in symlink, one line in hardlink. But conceptually, what do you achieve with this is our goal. Our goal is not to just learn how to build a symlink and a hardlink. And it's pointless. What are you going to use it for if you don't know what you're going to use it for? I can show you hardlink is very easy to build. ln space -s, there's symlink on the file, just like the tar command. Simple one line, you got your symlink. Okay? Everybody learned the symlink. Where do you use a symlink? I don't know. How do you use it? No clue. Okay? But now you sit down in a job and your manager says, make a symlink, make sure to the application. I think, yeah, I went to Nadeem Bhai's class. This idiot, he didn't teach us anything. He just showed us ln-s. Now I have to go and research on ChatGPT. And yes, ChatGPT will give you the answer at the moment. But it is good to know conceptually, get this technology out of your head, be good at it so that you can do bigger things that'll make you money. Okay, that's what we're trying to get to. So yeah, in a test, you can run this the way I did it. Add path here because you are you are in a test environment. Your environment is testing. So yeah, you want to add the path, play with it, play with it, play with it, play with it until you got it all right. You're good to go. Remove the path or leave the path because you're a tester or you are a developer. Okay, in DevOps environment, you don't want to remove it because this is not production environment. Who cares, right? Who cares?
Yes.
Nobody in the world is going to see it. There's only you are seeing this test. So who cares whether the path is there or the path is not there? Is it good for you? If it is good for you, leave the path. You don't like it, you're feeling unhappy, you want the Linux settings to be the product, factory settings, go for it. It's your machine. Fall in love with it the way you want to fall in love with it. I tend to leave the path in there because when we are going to, that's what for this machine, this IP, I don't know which machine I'm using here, 223, yeah, 223. I'm going to leave the path in here. Why? Because we're going to build our projects on this 223 from this point on. This is Khalid Khan's machine, and he will use it for Ansible too. So I'm going to leave everything here. Okay. Right. Very good. We're done with paths. And we have learned, ladies and gentlemen, today, we have learned about editing a path. Right there. There's your path. So rather than reading all this stuff, I've shown you exactly what to do. Now, when you read it, your mind can ignore some of this. Okay, do I need it? All you do is just copy paste, copy paste, copy this paste, copy this paste, run and see. I mean, but the create the first shell script, we did that. Convert the file into bash script, we did that. Right? We did all of that. It's done. I mean, oh, we are in the wrong one. Edit path, sorry. Edit path variable. Okay. So this is what you're saying. User types a command, shell reads the path variable, searches each directory in this order, directory 1, 2, 3, 4, and finds where your path is, executable found, command is running. Agree? Does everybody agree to this chart? So if you
Yes.
learn this, I put flow charts. आप फ्लो चार्ट देख लें काफी है आपके लिए समझना
Yep.
ये तो जी या Yes, Brother Alex.
No, I say yes. Yeah. Go ahead, sir.
No, go ahead, go ahead, go ahead. If you have a question, go ahead.
No. I didn't have a question. I was just agreeing to what you said. Yeah.
Yeah.
All right, perfect, perfect. So you can see that we have done a path. I'll probably match this from user game, snap, bin. Basically, I will clean up these files. These are my old notes. So I'll clean them up based on the teaching I'm doing today. Because I'm just teaching, I'm improving my teaching from last time to this time. Sometimes my teaching was a bit complicated. Now I've learned to make it even more simplified. So as I'm improving on my own teaching styles. So I'm trying and testing with our every cohort what works best for people to grasp the concept. Simple. So today you have all learned section one very clearly. Commenting, everybody knows what is commenting. Trust me. This is the easiest thing. Nothing to do about. If you go into your script, vi hello.sh, and if I came here and I put a comment on it, a comment like that, sorry, insert, it won't work for me. Like, so if I go in here, sorry, insert, okay, let's insert and let's come down and let's put a hash. Okay. And save, write it, save it, move on. And now let's run hello.sh or ./hello.sh. Nothing. Empty. The file is empty. Hello.sh. Nothing. Why is it like that, Azim?
Because we make it a comment, this
Right.
respective line.
We commented the line, commented it out. So, ladies and gentlemen, we are done with this section where we say commenting. Okay, commenting is very, if you look at in Linux, you have so much commenting going on. Look at vi, etc, ssh, ssh, d_config. Look at all the hash. Look at all the hashes there. Hash. Comment port 22. Now, we did talk about when we're doing OpenSSH that even though this is a hash, but in the default, in kernel, the army rules, the kernel of the machine, this is already defined as a default. So the comment, you have to read them two ways in Linux. Pay attention to what I'm going to tell you. दो तरीकों से आपने इसको पढ़ना है. There are two ways to read this in Linux. When you see a comment in any file, there is one thing you got to understand. Is this a hard coded value? Right? Is this hash? Is this hard coded? ये code है. This is the code in the kernel. This value, ladies and gentlemen, is a hard coded value. That is why this hash has no effect. This one does not say that, oh, your port 22 will not work. I'm right now using port 22. I'm in this machine using port 22. If this file was hashed, I should not be able to come into port 22. But I'm still able to SSH into this machine I'm in right now. All of you who are doing SSH, your files have this hash. Hash means commented out. But that means this should not work. This port should not be there working for you. But it is working for you. Why? Because it is hard coded. The kernel. In the kernel, it is port 22. They have a mapping of ports. There's a mapping in the C++ program. Port 22, SSH. Some ports are already hard mapped. So all this is telling you in this file, Linux is telling you, if you don't want this port 22, remove the hash and remove this to a different port. Change the port number. Only remove the hash if you want to change the port number. If you remove the hash, port 22 will work. But there are certain hashes which you have to remove. So if it is hard coded, no effect. Some are not hard coded. They're not hard coded. So when you get to a hash, it will have an effect. For example, in my file that I just have right now, this file that I'm using, here the hash has an impact because this is my own script that I'm writing, and I can see that there is a cat. I'm sorry, I can cat hello.sh. You can see that I have a hash. So if I want to remove the hash inside here, then I can simply just remove it by going inside hello.sh, and I can press insert, and I can come down, and I can remove the comment, and I can escape, write to it, quit, exit, and now if I run hello.sh, it is there. Are we clear? Okay, good. So we have completed and concluded on day 72 today in bash scripting. We have concluded section 1. I'm going to close section 1. Right? We are now going to go to section 2. Okay, we have 1 o'clock. Variables, intro to variables, very easy, very straightforward. This is the most important one. And then the arguments. We are just going to stop today at single multiple arguments. We'll come back tomorrow. And then we are going to get into mastering what do you see outside that confuses you, why people are so afraid of bash scripting. I'm going to show you the easy peasy easy. So now what we're going to do is we're going to talk about a variable, right? Now, ladies and gentlemen, I prefer if anybody we need to take a break, we can take a break. But if we continue until the next 30, 35, 40 minutes, we can conclude this class rather than taking a break. So I'm going to continue. If you need to take a break, need to restroom break, water or something, let me know. We can take a 5-minute break. If you want us to continue, let us continue, and we can end in 30, 40 minutes.
I'm okay.
I'm okay too. We can
All right.
continue.
All right.
Continue,
We
please.
can continue.
Okay, we can
Continue.
continue. We can continue. Perfect.
Let's continue, sir. Let's continue, sir. Let's go.
Okay. Okay. So we have we have for example a date command. Okay. Every time we type date, every time we type calendar, every time we type uptime, any of these commands we type them. Remember, they are all in our path, right? They are all in our dollar path. Now you understand what path means, because every time you type them on your shell over here, you will get an output. You will get an output. You will get an output. Okay. So these are all variables, right? These are all variables. These are called variables. Variables. Okay. Why is it variable? Because the date at the time is changing, so it's a variable. Okay. Now you guys are all have a plate in the house. I have a plate in my house. Every day, the plate, the plate is a constant. Okay. What you put on this plate, one day, whatever you're going to put on this plate to eat every day, your food, whatever one day you have rice, and then you have some beans. Okay, very popular food, rice and beans. Maybe you're going to put some yogurt. Okay, this is all variables. Okay, you put plain rice, biryani rice, right? So these are variables. Your plate is a constant, but your food that you put, your cup is a constant. You have a teacup and a coffee cup. This is a constant. Okay, that's constant. But what you put inside here, you put ice. If you don't put ice, this glasses, so you got solid, liquid, gas, all coming in here. This is all variables. Okay, but let's stick with our mindset of Linux. Okay, these are just some examples to help us understand variable versus your mailbox, for example, dock. You get mail every day, all of you. So you have a mailbox in your apartment, in your house. Okay, this is your mailbox. Mailbox number 21. It's a variable. One day it receives one package, tomorrow it receives another package, another package. So it's a variable. The box is not going anywhere, but it is able to take multiple values. Multiple letters are coming here. Letters, flyers, they're all coming in here, right? So this is a variable. A variable is a place where you can store multiple different values. It's able to take any value, multiple values. The difference between the programming languages and Bash scripting is you will learn it when I come to data type. In other languages, data types is something in Linux, you have nothing but variables, basically. That's it. There's data type, but the data type doesn't mean anything to Linux Bash scripting. That's why Bash scripting is so easy because you have one box and put whatever you want in this box. Whether you put a 2.14 value, or you put a value like this, or you put a dash, uh, you know, port 22. It doesn't matter to it. It doesn't matter what this script looks like. The box will take anything and everything. It's a box. Just like in your house, you have a box. You can dump whatever you want. Put your shoes in it, your socks in it. In other programming languages, this has a clear data type definition. Data type. Is it a floating data? Is it an integer? Is it a what do you call, variable? Is it a what and what not? No, sir. Linux's beauty is one box does it all, right? Whatever you want to put inside it, it doesn't matter. Okay. So let's say our box is called date. We're going to run a date command. Our box is a date. This box is a variable. Every time you run the date command today and tomorrow or uptime, remember time is changing, right? So it is going to take, it's a variable. These are variable. The values will keep changing, but the command doesn't change. So in the date command, the date command is the box, okay, that stores any value you like to store. That's it. The name of this box is date, and inside this date you can store any value you want. As long as you tell Linux date equals to this and store this inside it, it'll store it for you. So it's a open storage box, unlike other languages where you have to look at data type and Python and what is a string. Okay, we're going to, look at a data type. Is it a string? Is it a Boolean? True or false? It is this, it is that. So when we say that you don't need to learn programming, it makes your life easy because when you look at data types, there's nothing to worry about. You just have a box, and as long as you call this box whatever you want to call it, one of the boxes is date. And if you look inside this box, it is storing some value, okay? A variable value, a value that can change. Any value you want, the value will change. Okay, very good. That's all a variable. That's all what a variable is. There's no more rocket science to a variable. Okay, so let us do this, right? Um, let us do a quick forward in understanding what a variable is going to do for you, right? So let's go into a script around here. Let's go ahead. So we have, if I type date, this is a variable and it will always give you 125747. It's a date. So the box is called date and it's storing a value, a variable, right? Then you have a variable like uptime. Uptime is a variable. How many users? This keeps these values change. They're variables. Variable values are coming. That's why uptime is a variable, right? It's not a constant. You cannot type uptime today, tomorrow, 100 days from now, 18 will become 19 tomorrow. 10 days from now, it will become 28. 20 days from now, it will become 38. Time will change. Users will change. They are all variables. So very simple. Our job is very simple in this life with Bash. Bash is a beautiful language to learn and master because it doesn't have the heavy lift of Python and heavy lift of any other programming language. In variables, you got one word, do whatever you want to do with this word. Put something inside it. Call it ABC. ABC equals to 1, 2, 3, and echo ABC, and it's gonna echo ABC. Sorry, echo. Sorry, dollar ABC. What am I saying? Dollar ABC. So dollar is telling you, give me the value. Give me the value that is stored inside this ABC. Okay. So that's it. I've taken a value ABC, stored 1, 2, 3 inside it, and I said, show me the value like dollar, right? Dollar is a value. That's what you know, value. What's the value of your car? What's the value of ABC? What's inside this ABC? 1, 2, 3. Okay, very straightforward about it. So let's now go to our scripting. But our goal is to learn scripting. Now, we have VI, let's create touch. We'll create a, we'll call it variable dot sh, var.sh file, or we'll just call it variable dot sh script. Okay. So now we have two scripts. Remove, we have a variable. Yeah, we have, this is coming back later on. So we have a variable script, right? Now, if I'm going to go VI variable dot sh, insert. What is the first line that I need to put in shebang?
In this.
Hash. Shebang. Hash. Hash. बताइए hash. Hash. Exclamation mark.
Exclamation mark.
Bin and bash. Very good. Now, we are going to say echo, right? Echo. And what is your name? Stranger. Okay. What is your name? Stranger. Hit enter. Then we can say, let us read NAME, the new name. Name is where I'm going to store a variable. So whatever I'm gonna put in here, when this read means give me a name. If I put a name inside it, it will show me the name. Let's run the script first. Let's run the script. It's a very nice top-notch learning script on the planet Earth. You can do for mastering the subject, some of the best teachers, that's how they teach it. Okay, that who I've learned from. Okay, so I didn't grow up learning this. I learned it from somebody. I'm just telling you some of the best people teach it this way, right? And then you're gonna echo hello. And I'm gonna put in there dollar name. Okay, dollar name and exclamation mark, and I'm gonna close the bracket. All right. Now let's run this script. Let us run the script. Right, quit, done. Let's run the script variable dot sh. Oh, permission denied. What should I do, guys?
Right permissions.
Very good. U
U
plus
plus.
X permission on this variable. Variable dot sh. What is your name? All right, let's start with somebody here. Let's start Mr. Walex. What is your name, stranger Walex? Hello, Walex. Let's run the command again. Let's give the variable hello, stranger. Okay.
It will
What is
work,
your
man.
name? Yeah, Azim. Hello, Azim. Hey, there is a hello, stranger. What is your name? Let's call it Khadija. Okay, what is your name? You're changing the variable. Every time I'm saying reading the read command, it is taking an input from me and it is assigning it to. So what am I doing here? What am I doing here? I'll show you what I'm doing here. My first line is the shebang line. Everybody agrees? Shebang.
Yes.
My second line is a line in which I said echo, okay? And I can check it here. Hold on a second. Let's do it this way. Let's do this. Okay, this is uh Ibrahim. Okay. So let's do it this way. Cat, our variable dot sh.
Sh.
Now you can see clearly. So the way the program comes, it reads the first line. It says, "Listen, this is a bash script. So read the first line. So read the first line. Read the second line. The second line is saying, "What is your name, stranger?" Okay. But right after the first line, it realizes that you have put a input command called read. This is input command. If you want to give something to your script, you say, okay, I'm going to give this script uh, a name, right? So let me do this. Let me do this real quick. So let us SSH root at 192.168.1.123.
233.
233. Sure, good. Thank you. 233 ABC. Uh, so this is our NIT machine. You guys are welcome to go and look inside it. It's, okay. So let's remove this machine to the side, right over here, and let's remove all of this stuff here. Okay, and let's stop here, right? And let's get this guy on the side here. So okay, very good. So we are saying, let us clear this command. Let's clear here. Okay, and here we are going to clear it too. Let's come down here, and we're going to cat your variable dot sh. Uh, so that is the cat command. So when we come over here, let's go apple to apple. When I say variable dot sh, when I press enter, so first thing it is going to do is going to hit enter, and it is going to go and look at this script. And we're going to do this. We're going to add, let me see if I think we can add a minus x to the end of this. Minus x is your debugging on. Okay, stranger, see, let me not do that right now. We're debugging is the next part. So one thing at a time. So I'm going to just run the variable command. Okay, variable dot sh. What is your name? So the script has come here. It has gone to read this, but it has stopped. It's showing nothing. Okay. So what it want is coming here is saying read. So you're going to put in a name and you're going to say the name is going to be, let us say Akin. Akin. Okay. So Akin is a name that is getting stored. This name that you just typed in is a variable. It gets stored under this word name, right? And then the next command that it's going to run is going to say hello, and it is going to take whatever this name Akin is inside here. It's going to come down from here and put it over here. Because now name contains the word Akin contains this. So the name variable has the name Akin in it at this point. So every time we come in here, we are changing this variable, what's inside the box called name. And if you want to access the box, you have to use the command $name, right? What is the value stored inside name? What is the value stored in your variable called name? That's what this means. Value, dollar, the value stored in under name. So what's stored in name? Well, I said put whatever you want, put Akin. Now I've got Akin. When I go back again and run it, I say Azim. Then I say Ibrahim. Then Khadija, Aisha, whoever is here, right? Adelovo, whoever, Sahid, Wolex, Hassan. So now Zakaria, clear all. Go ahead. Any question? Any questions?
And no,
Right. So we said that if ABC equals to 1, 2, 3, and I said echo dollar ABC is the same thing as saying dollar name. Is that not the same thing I'm doing here?
Right.
Yes,
yes.
I'm saying the same thing here. Echo, I'm saying echo. I'm saying ABC equal to 1, 2, 3. I'm saying name here equal to keen. So
Yeah.
I'm doing the same thing. So when I hit this enter, is 1, 2, 3. Now if I said that ABC equals to Akin, and then I said, give me the echo ABC, Akin. If I now said echo ABC equal to Azim, okay, and I've said echo to echo Azim, because it's saying echo the value stored.
And ABC.
Right. So we are running a script by changing the stored value. We are not fixing the value. We are using a command called input, right? You could have called this ABC if you wanted. Okay. We didn't have to call it name. Let me show you. Okay. If I go in here and I said variable, and I came down insert, and I went and changed, called this, if I call this ABC, I have to make sure that my output will be my value
Should be
stored,
dollar
it will be
ABC.
called ABC. Are we clear, gentlemen?
Yes.
Yes.
Now, if I come in here and I run my script, and I said, okay, give me the variable dot sh, okay, and I said, give me a name, Akin. Now, in the under the hood, doesn't matter if I called it name or if I called it anything, because now I've called it, I'm getting this variable. So I'm taking, I say, what is your name? It comes here. What is your name? It's the line goes to the next line. The minute it sees the read, it's input. So the program has stopped. So if I run the program, my script, it has stopped. It has a line over here. It says, hey, give me something. Give me a value. Give me a value. Okay, the value is 1, 2, 3. Hello, 1, 2, 3. Right?
Okay.
Are we clear?
Yes.
Very good.
One question, Nadeem bhai, over here.
Ji sir.
So,
Ji sir.
if we want to store the results from our full command, let's say we pass the command one time, we run the script one time variable, and we give the name 1, 2, 3. Next time
Right.
we give the name Nadeem. Third time we give the name Akin. And if we want to store the results, like how many users run that script and they provided the results, so we need to add some different lines in that, right? Or
We are
we
going to
can
come
do
to
it.
that. Yeah, but
Okay.
the beauty compared to other programming languages, उसकी खूबसूरती ये है कि you have one box. Initially, we called that box name. So we called it
Okay.
name.
Yeah.
Then because ABC, nobody knows what is ABC. That's why we give it something our mind can appreciate, right? I mean, we
Yes.
are human beings. We cannot be like a baby, doing kaka kiki. You put kaka kiki, everybody, what the heck is kaka kiki mean? Is majhul. You can't understand it. It's like a baby talk. So that's why we assign meaningful, uh, what do you call words, the choice of words. So we called it name, but we could have easily used ABC. So beauty about Linux is whatever you store in a variable called name, for example, and was Akin, it is going to stay there for as long as you keep it there until you change it.
Okay. Yeah, that's okay.
It
That's the
is not
idea.
going away. It is there forever. That's the beauty of Linux. So it will siyaq or sibaq, context. What do you want to gain? And we are going to learn. We're going to see that. So once I store Akin, Akin is there. Akin is not going away. The variable name has got Akin stored in it. So if you are writing a program and you stored Akin in the program, the word, if you use the statement name anywhere in the program, you use name. That stored variable is what you're going to be using all over the program. Make sense?
Yes.
You're not going to get so the line by line you're executing line 1, line 2, line 3. So if you took an input called Azim, okay, then Azim is going to be used in anywhere in your program. You use the $ and you say the value is Azim, the name, what is stored here, it's going to take that and run that in your script.
Yeah.
It is
Until
not
it
going
is
to change
replaced.
anything.
Yeah,
Yeah,
until it
unless
is
you
replaced by.
until it
Okay.
is replaced from the time where you redefine it.
Okay. Okay. Get the idea. Okay.
And
Thank you.
Nadeem, by the owner has the permission to change the name
Yes, sir.
only.
Yes, sir. Only owner can change it because remember, that's a very good question. Remember that आपकी जितनी भी scripts है ना, all your scripts यहाँ से आप permissions बदल रहे हैं. If you are the owner, then you are. Now, if I made this script Chamod 777 variable, right? Everybody has permission to destroy the script, play with the script.
Yes.
So if I want to really just restore it back to 7 22
0, 0.
22 read, because remember that 644 are original permissions on the file.
Yes.
So if you want to store it back to where you want to leave the 44 alone, read write, and you don't want them to write anything to it. So what you want to do is so if you are the owner, your permissions are read, write, execute 7. The group, you want them just to read. So then you just have 4. And you want others to just read. Then you have 4. Then you have variable .sh. And if you look at your stat command of variable .sh, you'll see that it'll give you the permission. 744 is only you have the full permission. Everybody can just read. They cannot do any changes to your script. So this is how you will control your script through permissions. परमिशन के जरिए से आप स्क्रॉल इसको कंट्रोल कर रहे हैं. Okay?
Okay.
Very good.
Okay.
Let's keep on going. और कोई सवाल? Let me know. Any questions?
No. Sure.
All right. No problem. No problem. So let us keep on going a little bit and let's clear this. So we said that if we wanted to go age is equal to 27. ठीक है? And if you go answering echo age, echo $age. Okay, हमें हमेशा चाहिए होगी value. We always want, give me the value that is stored in age. That's how you read this line. Give me the value, मुझे value दीजिए जो इस चीज में stored है. That's how you'll master this language. Very simple. Give me what is stored in age. 27. Now, if I decided to change age 27 to age 23, 200 to 23, 22, okay, and now I run it, age is 22, you see. And if I said color equal, now don't say space, no spaces. Don't make spaces like this. You're not doing a Microsoft Word document to please anybody. Okay, so there are no spaces. This is a computer language. Color equal to blue. Okay, then I'm going to do echo blue color. What is stored in the color? Blue. How about if I did color and I removed this? What would have happened? Still showing blue. You see? So the reason why we use for strings, you see the beauty of Linux is with or without that, it is able to give you the output blue because it doesn't care if this is a string. In other languages, this command will not work. This command in Python will work, but this will not work because it won't recognize this as this is a string. It needs to know, hey, is this a string? Is it a number? But if I can say color equal to 2.144, sorry, oh, color equal to 2. So what is color? 2. Right? In your mind, you're thinking blue, black, and green, and white, and yellow. But to Linux, this is just a variable. Call it ABC, call it color, call it whatever. But you will use the variable, and we're going to do that very soon. So, okay. So, what we have found out is, for example, there is a thing called pi value, right? Uh, if we do echo dollar pi, sorry, echo dollar pi. No value there. Echo, let me see the dollar, no value. So it hasn't stored any, like in most programming languages, pi has a value of 3.214, whatever that 3.14 or whatever that value is. So you can see that Bash doesn't care about all of that that's going on in the world. It wants you to tell Bash, hey, what do you want me to store? आप जो देंगे मैं ले लूंगा. So it doesn't. Other languages don't work this way. Other languages are very complicated. You must know the difference of the data type. Is it a string? Is it a boolean? Is it a variable? Is it an integer? Is it a floating value? It is blah. It is blah. It is blah. So it has to. You have to put it in your brain to memorize. Okay. So let me know how to handle a float, how to handle a boolean, how to handle a true false statement. So we are opening the door for you for Python. Remember, the beauty about this is you don't have any data type to worry about in Bash scripting. Come up with your color, your ABC, age, give a name, and store a value, and move on. Play with the game. Play and have fun. That's why Bash scripting is so known as Bash scripting, not Bash programming. Even though it looks like kind of like programming, well, there is some programming, but it's scripting. Okay, that's the difference between scripting and programming. Now we are getting to the end, ladies and gentlemen. We are slowly and surely getting to the end. Okay. Now there is another thing that there's a built-in command, built-in command called you will see this sometimes read only. So if you come across read only command, okay, the read only command is a command that you want to use if you want to make something in a script constant, right? We saw that early on that when we try to echo the pi value, which is a mathematical value, right? Whether it is pi or whether it is pi, either way, there is nothing coming out. There's no value being assigned. Let's say you want to make this constant, meaning any time in your mathematical model or wherever you're going to use a mathematical constant or some constant of chemistry, physics, some constant that you have to use, some constant that you don't want to change. The only way you can make it a constant and never change it is just type in the read only and call pi equal to, let's say we can call pi equal to, if you're going to use this, or you can use pi, which is much better, pi equal to 3 point, what is the value of pi? 3.1427, something like that. So if you do that, it will make it constant, right? It is going to be constant. Now it will not change in the, because you have told the entire system, the kernel, the bash scripting, whenever the word value pi will be used inside your script or outside your script, it is now defined in the system and as a constant 3.143. This value is not changing. Okay, so that is why we need to keep in mind how to do the constant. Now let's come to the most important part called command line substitution, right? Command line substitution. How do you learn command line substitution? Very easy. Okay, we have two ways in Linux today. Let me bring this down. 15 minutes and counting down. 20 minutes max. We are done. Okay, guys. This is the fun part now, where you start using bash scripting. So we have something called command substitution. Substitution. Oh God, whatever it is. Okay, command substitution. We have already kind of seen the command substitution. We got introduced to command substitution right here. But let's go. You will pick it up. So the syntax that we are going to use, syntax, is you're going to have a variable, okay, equal to a $sign, and you're going to wrap it up like date. Okay, that's one way. Okay, and the other way to have the syntax is you can remove that. Okay, and you can remove the $sign, and you can put 1 and 1 like that. So there are two ways of defining a variable if you want to, but we already saw. Well, we'll see. Let's play with this a bit. So no, without wasting too much time, let's jump into it. Okay. So if we have day today, right? Let's say we have a command called day, which is equal to your let's make it even easier. Let me use that today. Okay, today is equal to I'll say dollar date. And if I do today, echo dollar today. All right. So this is not that didn't go through. So let's see what has been deprecated. I need to see if we are gonna go day and we take that off. All right, let's take that off. Equal to date. Okay. And let's see. It will. Oh, I see why. I see why. We had a mistake here. Okay, my bad. Okay. Date. Okay. And let's go back to that one. Let's go back to this guy. All right, dollar day. Perfect. Let's do that. Let's do the command this way. And let's do the command today. Yep. That today. Yeah. That's the difference I want to show you. That is exactly what I want to show you. Right. So you have one way to that you can do today, and I have defined a variable. This is a system variable, the date command, right? Now, if I use just so if I go with a dollar, so this is the way that we are going to assign, we are going to substitute, right? Because we want to substitute uh, a value using the date command. But let's keep on going. I'll show you what I mean here. So we run echo command, echo date, echo at today. It gives you the full date. So I stored this date uh, variable inside today. That's what I did, right? I could have just run date, dollar date, but this is just for showing purposes. Okay. You can say mycal, but if I did, for example, mycal equals, um, I think um, cal 2021. See if I'm on the right track or not. Let me see. I'm looking at my old notes here. Sorry, dollar mycal. Yeah. So okay, forget that's what we've already done. So that's not the substitution we're talking about. Let me scratch that off of my notes. I was just looking at my notes. What am I looking at here? Okay. Now we are looking at, this is the part that gets interesting. If you want to know your kernel type, this is an interview question all the time, -R. It's going to tell you your kernel 5.14. When we start up the machine at boot time, you will see this kernel. This is your kernel that I am in right now, 5.14. This is the kernel version that is running on my machine. Okay. This is the kernel through which the operating system is talking to for all the hard coded values and C++ program. This is the kernel we're talking about. Okay. Now, if I wanted to sign this kernel was a variable that I want to define in my script. I would have to use equal to $, bracket, open and close, and then put inside my uname -R. Okay, that's what I'm going to put. And what is that going to give me? Um, that's going to give me my dollar kernel value. Okay, because we are going to build a script. I'm just showing you some baby steps here. So if we have stored a system level variable, which is uname -R, the command that I'm running that is recognized, and I'm storing that output that this gives me stored in the kernel, and I can echo that output value inside the kernel is the exact value that I have up here. Now, there is another command called cat, okay, etc OS release. Okay. Now look at all of that mumbo jumbo stuff that you're going to get here, right? So I can basically do a bunch of things here. I could grep for, I can do cat etc, right? And I can pipe that output by grepping for, I have name, okay, name equal to that I want to use, for example. Okay, grep, you can use -I. -I gives you, whether you type N or you type N. That is case insensitive. But let's just move and remove that for now. Very powerful usage of that. So what you're going to do is grab name. Okay. So it finds you various places where you can find the name, right? Maybe because all you're trying to do in your script is to find a specific line that you want to print out. Okay. So one of the things that I wanted to highlight at this point is these are called, there's a word for this. Okay, you will hear this and don't ever get confused. There is a word for this. Okay, a word for all of this stuff. It's called regular expressions. typically you will see them regex. Why am I telling you that? Because when you look at logs tomorrow, when we do a log project, you will see something in there called regex. So regex messages are nothing but regular expressions. Like this is a regular expression. It has, so maybe a message contains all of these expressions. So that would be in a log called a regular expression. That's why I'm bringing you here and showing you what we're doing. Okay. Now we had a command called grep, and we have a command called egrep. Okay. And now we have a new command in Linux that has kind of eliminated egrep and just said you can go grep minus capital E. Okay. This is the new Linux command where egrep is kind of, but people are still, they're not, this is good, this is good, this is good. The new Linux distros and Apple, if you go in your company or new work you're dealing with, you'll see egrep hyphen capital E. If you look at ChatGPT, it's going to bring out grep hyphen capital E. Reddit community is going to minus capital E. So what is the difference between grep and egrep? Okay. So one of the things you need to understand is that the E here means extended, right? So you have grep. Okay. What is grep? Oh, my computer is out of the way. Let me get this out of the way. Okay. You have grep. This is R. This is called basic regular expressions. egrep. This is called extended regular expression. You don't need to worry about all this. This is not important to us. Okay, I'm just showing you. So this is called a regular expressions. That's what grep does. It grabs grep command and egrep commands. They work on regular expressions and they work on extended regular expression. This is a regular expression. Now you will understand what I'm trying to tell you. So if I use grep, I can grab, like grab, right? Grab from that. You can grab from a bag. If this is the bag, this is the box of different things. By running the grep, you can grab any regular expression. And using egrep, you can also grab. Now, the only difference between using these two commands is that when you type egrep, okay, egrep, and we have grep, right, which is literally means grab from a go and get me this thing over here, get me this expression over here. Let's take this over here and let's do something with it. These are regular expressions. So what does this e extend and this grab mean? If they're all regular, then what the heck is an extended regular expression, right? For the rest of your life, this is the only most difficult part of programming that you'll ever get to encounter. There's nothing difficult. It's just the way you got to learn this, right? So if you do egrep, you're going to have to put open a bracket here, open a bracket here. And you're going to have a little thing here called a caret. They call this caret. Little hat, like a little hat. You have to put this little hat. This little hat is saying that grab anything that looks like name equal to looks like. Does it look like this? If there's anything here that looks like name, then grab it. That's why the only difference is you put this in the grab statement. That's the only change. Otherwise, grab name and grab this, almost the same, nothing different. Okay, so that's why the grab command has gone to grab minus E. Okay, and then if you do the grab minus E, you have to do the same thing here. You still have to put the hat. So you're merging the grab command and the egrep command, and you're putting them all in one shot. So this is the new Linux way of doing it, but you can use these successfully. They're very nice to use. Let's play with it a little bit. clear all the drawings. Okay, let me clear this. Okay, we have to write some programs here. So let's do this. So this is the old school, the new school. So the new school is saying, okay, grep hyphen E. Okay, and I'm gonna do dash dash. I mean inverted commas. Sorry, with a space, and I'm gonna put in here a hat on the number 6 key. I'm gonna look for name equal to. Okay, and where am I gonna look for it? I'm gonna look for it under etc OS release. This is the new school. This is the new school. Okay. So if you ever see this, you'll see a lot of this on the internet now. So don't be scared. This is the new school. All you're saying is I'm going to grab and I'm going to integrate egrep, any extended grep methodology, and I'm going to look inside this folder for name equal to. Okay, I want to do that, right? So there you go. It has grabbed the name equal to Rocky Linux, which was there, right? We were able to use the grab command and we were able to see 1, 2, 3. Here we are saying start looking for name equal to, right? This is the one which is name equal to, is specifically only name equal to. This one is pretty name equal to. This is CPE name equal to. I want you to start with that which is name. This is the only one out of the 3 expressions that starts with name. That's why I put this hat. Starts with name. This starts with pretty. This starts with CPE. This starts only with name. Are we clear? So this starts with name, right? So there you go. You have it in front of you. Now, let us go and see how we can wrap up the day with a very small script that we are going to write. Okay, we have been what do you call this thing? So down the line, we are going to learn that we can build our script as, let's say we were going into VI system, or we have one for system. We have one for system. So VI system dot sh file, insert. I'm going to go shebang, which is hash, this bin bash, right? And if I wanted to store here a value, okay, I wanted to store a value, and we're not going to do this now because this is a project we have to do. I'm just showing you the difficult part that we have finished. So I can do distro, and remember, every time you want an output, you're going to come in here and you're going to say, okay, what do I want? I wanted to grab hyphen E, and I wanted to have a name that I'm going to pull out, starting with name equal to that. That's coming out of etc OS release. Okay, that's the output. Okay, that is the output. Did we get that as name equal to? Why is it giving us all 3? So it gave us initially just the name. Okay, fine. So we're gonna come in here and we are gonna grab this. Okay, grab that and post it there. Okay.
So you have to
And
put the cap sign in the name.
yeah, you're right. You're 100% right. Okay, dollar. Okay, and we enclose this in the bracket. I'm just showing you how difficult outputs can be managed in bash scripting. You have to test them on the right first, then you come and copy them and give a name to it. So whatever this output is coming out, we don't want all this out. What am I doing wrong here? Can you tell me?
Cap sign on the name, inverted commas between
Wow,
after
mashallah,
E.
mashallah, mashallah. Oh yeah, zabardast, zabardast. Excellent, 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 excellent. Okay. Now, this is somebody paying attention. So we don't need all of this. We just need that. Now, clearly, if I run this, I'm going to have a million errors because I don't have the gap. I just saved myself a huge headache. Now, distro equal to that. What is the next command, guys? Very simple. Echo dollar distro. Command not found. Okay. Now, since the command is not found, we are going to go ahead and do something called debugging. Okay. We're going to do debugging. So we have two things to learn before the day is ended. In fact, we can end it on debugging and come back and start arguments. So I'm going to stop at debugging, showing you how debugging is done. I've intentionally put some mistake that your eyes are not seeing. So maybe I'm seeing it, I'm not seeing it, you're seeing it, you're not seeing it. So let's allow Linux to tell us what's going on. So if I go into VI, right? Let's go to VI system.sh and we go in insert.
Echo के
Sure.
बाद space नहीं की हुई.
We'll minus पता अभी बेफिक्र debug को काम करने दे. So minus X, I was in an interview and I forgot one day. I said, how do you debug your script, guys? I said, I had X. He said, do you add minus X or plus X? So funny thing is that plus X means, I'll show you what it means. So you have to add minus X, right? And then when you come down here, you're going to say set to, you can set it to, what do you call this, plus X. And if I put a comment here, you can put a comment. It will not read the comment. And the comment is debug is off. Okay. This is what it means. But I'm just showing you what a debug is off. So I've
इतने
turned
बड़े
it
घर
on.
की जरूरत तो नहीं है. एक कमरा काफी है. एक कमरा एक वॉशरूम है. एक किचन.
Right. So we have turned it off. Okay, let's see. Don't be confused, guys. You're going to play with this, you're going to enjoy it. Now let's run our script one more time. Debugging system.sh. Okay, command not found. System.sh not found. Why? LL. Dot system.sh. Right. So why is the command not found? I'll tell you why. Because if I go to this computer here and I run LL and I run system.sh, it runs here. But in this machine, it does not run. And this is what I wanted to show you. So when we leave this machine today, or we start a new machine, right? It is not recognizing, this new machine is not recognizing, this new terminal is not recognizing the path. Okay, let's look at the dollar path in this machine. Right? And let's look at the dollar path in this machine. I see here and I don't see here, right? I see it. New edit. Okay. So two things that we need to understand. So this is like one of the main points of confusion for a lot of people who are learning Linux, right? The export that we used here, this one, we used export command on the first terminal, right? We used export right? And we created a path equal to this and whatever we did that, right? So so this command is temporary. That's what it means. It is not persistent. It is not persistent. So how do you make it? How do you make it permanent? Anybody?
प्रोफाइल में जाकर के
Read.
इसको ऐड करें सिस्टम प्रोफाइल.
Very good. In your initialization files. Yes, sir. In your bash RC file, you can change that. Very good. Profiles may. So our initialization files, we have to this is okay in the working temp when we did the export. So when I open this one, the path is gone. You don't see the path here. So I would have to make, if I want to make this permanent, then I would have to go to bash RC file. That's coming in our project. So don't worry about it. But I wanted to show you that I was running the command here and it says continuously saying it cannot do it until I ran this one. ये मुझे चलानी, I had to run this one to make it work. So this is your default way of running a script. Okay. This one is because I have it in my path. Okay. So that's one thing that we need to understand. So let's end this class and let's look at the debug. So let's look at the debug in both sides. So this one, if I say variable, there's no path. If I say variable.sh, there's a, sorry, control C. We are doing system.sh. So it says line 6. Line 6. It is looking at this one. Okay, distro equal to Rocky Linux 9. It's breaking it down. Oh, there is a problem right there. There's no gap in between the two. So we have to basically go into our script. We can go anywhere we want. Vi system dot sh and insert, and here we go. Okay, one second. I want to remove this garbage. 1 second. We're done, guys. We're done. We're done. We are done as I had promised you. Uh, so that the thing I want to. So what happened is I want to see if I get the syntax. So if I go in here and I type .noh, right? See, if you remove the noh, no highlight. So I've been highlighting this one. And if you just go no highlight, I'll remove the highlights. And you want to be always with no highlights. So if you ever want to set that up, anyway, that's not big important. I just wanted to show you that one last thing. So now we can see clearly that our script is going to run fine. System.sh. Okay. Now it's showing me still some bunch of debugs material. Set the debugs to +S. So let's go ahead and remove the debug line. System.sh. And let's just remove. We don't need the debug. So what people do is rather than putting it there, they just put the debug set -X, which is, and they just say to it, debug on. Now, if I go ahead and just set this, put my hash, right? And I put my hash and I save it. And I run my command again. I'll get my Rocky Linux 9. That's what I wanted. That's the only thing I wanted out of this. All right, ladies and gentlemen, we will come back tomorrow and we will get into writing some good scripts. It is enough for today to absorb. Any questions so far?
No, sir. All good.
All
Okay,
good.
sir.
Data
Thank you
type.
for that.
Thank you. Look at your
First
notes. Go over your notes. These are very easy. I've already said it here. Data type describes the kind of information. Integer, this. You don't have anything to do. Just read these notes. Now, with your mindset of what I just did, read the notes, come back, learn something out of it, teach me something that I didn't do right, because that's what we're here for, right? Um, and then constants, we have pretty much covered everything. All right then. Thank you very much, everyone. You all have a nice day or evening
Thank
or
you,
night.
sir.